Okay, this is a video about linear modeling. So we're sort of modeling with the function mx plus c. A factory has a machine that manufactures glasses. It costs $60 to set up the machine and 50 cents for every glass made. Write down the cost function in the form C of n is equal to mn plus c, where n is the number of glasses and cn is the total cost of making them. What's the cost of making 800 glasses? Okay, let's deal with that bit first. So we're told that C of n is equal to mn plus c. What do each of these things mean? Well, the c represents the setup cost of the machine, okay, and the m represents the cost for making each glass. So we've got $60 and 50 cents, a mixture of units here. So we're going to turn everything into dollars. So it's going to be C of n is going to be equal to 0.5, which is 0.5 of a dollar, times n. So because every glass is made, it's going to cost 0.5. So if 2 were made, it's going to cost $1. If 4 were made, it's going to cost $2. And then there's an initial setup cost, so plus 60 is the setup cost. What's the cost of making 800? Just a little comment here. Make sure the units are the same. What's the cost of making 800 glasses? Well, for that, we want to find the cost for 800 glasses is that n will be equal to 800. So C of 800, so replacing n with 800 is going to be 0.5 times 800 plus 60, which is equal to $460. Right, another factory also makes glasses. Its machine costs $45 to set up and then 60 cents for each glass made. Write down the cost function for this machine in the form of D of n is equal to mn plus c. How many glasses were made if the total cost was $345 in the second factory? And what is the break-even point where the two factories charge the same? So 45 to set up and 60 cents for each glass. The general form of D of n is mn plus c. Remember, this is the setup. This is the cost. M represents the cost for each glass. Units have to be the same, so 60 cents is going to be 0.6 n plus 45. Right, we need to know how many glasses we can make for $345. So we put 345 into equal to 0.6n plus 45, and this is like an equation which we can solve. So the opposite of adding 45 is to take 45, so that gives 300 is equal to 0.6n, and then the opposite of multiplying by 0.6 is to divide both sides by 0.6, so we're going to get that n is equal to 300 divided by 0.6, which is 500. Therefore, 500 glasses were made. Right, the final part, the break-even point, if both factories were to charge the same amount, then C of n would have to be equal to D of n, so therefore 0.5n plus 60 is got to be equal to 0.6n plus 45. So the way to do this is on our GDC. So going to our GDC, going into a graphing mode, and we'll put in the first function, which is going to be 0.5. We'll have to put it in terms of x plus 60. Right, when we enter this, nothing appears, and the reason nothing appears is that it's all gone off the scale. We'll find the scale in a minute. Let's just enter the second one. So Control G. We're going to have 0.6 x plus 45. Okay, when we enter that, again, nothing happens. So we need to do a little bit of zooming here. So Menu, Window Zoom, and we're going to zoom out to begin with. So put the center somewhere over there because we're only really going to be interested in positive thing. You might have to do it more than once. Now function started to appear. Okay, a few more times and we'll probably be there. Okay, press Escape. And now we probably want to do a box zoom as well, so I'll show you how to do that. Window zoom, go down to number 2, zoom box. Basically what you do is you plant the first corner. So we were interested in this point of intersection, because that's a break-even point. Point that down there, and then make sure we've got a bit of the axis, and then let go, and then we get it. Press escape, separate the labels up. Okay, we're interested in finding the point of intersection. So the point of intersection, we'll go to menu, number 6, analyze the graph, number 4, intersection, and then we need to go to the left of the intersection, press enter, and then to the right until we've gone past it, press enter. So we know that N would have to be 150, and this will cost $135. Going back to this, what we need to do, there's the screenshots of that. What we need to do now is draw a little graph. So this is N, the number of glasses made. This is the cost. Draw roughly the first graph. C of N is equal to 0.5 N plus 60. So remember that's the blue one. And then draw on the red one. Sorry, then draw on the red one in the right place. Okay, so 0.6 has a steeper gradient, so it'll be up this way, and 45 is lower than 60. Only roughly needs to be in the right place. Mark on the point of intersection, read off on the graph, which is 150, 135. So interpreting that, the break-even point is when both factories make the 150 glasses, and the cost of this, and this will also cost them both $135. Okay, so this has been a video to show you the introduction of a linear model using the idea of f of x is equal to mx plus c, and the GDC as well, some GDC techniques, and I thank you for watching this video.